Here we have some word problems. Excuse me. I think we're going to have to use a system of equations to solve these. Let's see what happens. For the first one, I think it's always important to be really clear what your variables are. So why don't we let x and y be what? Well, we have a total of 8,000 invested in two accounts. And we want to know, well, and we're told the interest rate on each account, and we're told the combined annual interest, and we just need to know how much is invested in each account. So why don't we say x is the amount invested in the first account? And the second, obviously then y is the amount invested in the second account. Let's put that here. 1 second. And erase this and put second, okay? Now, let's take a look here. We know that the total amount invested is 8,000, right? So right away we can say something about x and y. We can get an equation using x, y, and 8,000, right? Doesn't it make sense if I do x plus y, I would get the total amount invested? So x plus y is equal to 8,000, right? So we have one equation. But really, to solve for x or y as a number, one equation and two variables is not good enough. We need two equations and two variables. So the other equation is probably going to be obtained by looking at this other information about this interest, right? I think we did a problem earlier today about a computer raising, that was question number 3, I think, right? Was I right? Yeah. What does number 3 look like here? Remember when we did the amount that came from this 5.5% increase? We multiplied the rate by the variable. This is actually what we want to do here as well. How would it turn out? Well, look, the first account, we're going to invest X in that one, right? And in the second account, we're going to invest 6.5%. Now, if you invest X dollars in an account that pays 5% interest, how much interest do you get back? Well, like I said, you just change the 5% into a rate, and then you multiply it by the amount of money you invested. So this quantity right here that I just wrote down represents the amount of interest earned in 1 year if you invest X dollars at 5%. Now, we have more interest, though. We have interest earned from the second account as well. How do we get an expression for that? Well, same thing. We're going to change this 6.5% into a decimal, so 0.065, and we multiplied by the amount we invested, right? This expression that I just wrote down gives us the total amount of interest. And they actually tell us that it's 467.50. And look, we have a system of equations now. Let's solve it. We could use any method we want. I think I want to use substitution. Why don't I isolate for x here? So x is 8,000 minus y. And what I'm going to do is I'm going to recopy this equation here. But instead of writing x, I'm going to replace it by something that it's equal to. Namely, I'm going to replace x by 8,000 minus y. And the rest stays the same. Notice now everything is in terms of y, so that's good. Let's multiply out the brackets. What is 0.05 times 8,000? 400. And, oops, there's a 0 there. And the rest stays the same. All right. As we mentioned before, it's nice to have all the y terms on one side, all the letter terms on one side, and all the number terms on the other side. So 467.5 minus 400. What is it when I add these here? Negative 0.05 plus 0.065. I get 0.015. Why? When I subtract these, obviously I get 6750. So now to finish this, I just got to divide both sides by the number in front of y. So let's see what we get for y. This is going to be the amount invested in that second account. So 67.5 divided by 0.015. $4,500. It's nice that it's a nice whole number. Makes us confident that we have the right answer. And let's look up here. X is 8,000 minus y. So we can just find x very quickly now. It's going to be 8,000 minus the value of y we just found, which is 4,500. What do we get? 8,000 minus 4,500 is 3,500. Okay. Now, we should really write a little sentence, right? Let's say something like this. The amount invested in the 5% account is, that's X, right? So is $3,500. And in the other account, which is the 6.5% account, there is $4,500 invested. So let's just check it real quick. What if we do 3,500 plus 4,500, we get $8,000, which is good. That's what we started with. And let's see if the interest works out. If we do 0.05 times 3,500, that gives us 175 interest for the first account. Why don't I write that over here on the side? And if I do 0.065 times 4,500, I get $292.50 for that interest in the second account. If I add those two together, I get 467.50. And that's that number that I was supposed to get. So we have the right answer. So our answer is this. Whoops. Sorry if it's a little bit messy. Good. Let's continue. I'm just going to recopy this down here so we don't have to flip back and forth. Notice this one's talking about the store selling two different kinds of computers. So right away I'm thinking, let X be the number of the first computer, number of the first computers sold, and Y is the number of the second computer sold. I'm not sure if I'm right, but that's just my first guess without even reading the problem. So let's take a little closer look at it. So they sold a lot of computers, they made a lot of money. And there's two types of computers. The first one sells for this much and the second for this much. Yeah, so definitely we're going to... And notice how they want to find how many types of each computer sold. So that's a clue that maybe that's what X and Y should be. So why don't we say... sometimes I see students, they write stuff like this, like X equals first computer. That's not very good because X is a number, right? First computer, that's not a number at all, right? You should try to be, the more precise you are with what you call X and Y, the better guided you'll be later of how to set everything up. So I think we should say X is the number of the first kind of computers that were sold. I know it's a lot to write, but the more precise we are, the better. And similarly, the Y is going to be the number of the second kind of computers that were going to be sold, right? So let's put that in. Now we can set up our equations. We're told that they sold this many computers, right? So x plus y should be the total number of computers they sold. Now, if you sell x of the first kind of computers, and each one of those is 450, how much money are you going to make just from the first kind of computers? Well, that's just simply the product of those two, right? 450 times the number of those computers are sold. And then I got to add it to the money I made from the second kind of computers sold. Those ones go for 510, and I sold y of them. So I'm going to multiply those to get the total revenue from the second kind of computer. And then I'm going to add them up to get my total revenue. And we're told the total revenue is this number here, 494,700. All right, I'm going to solve this the same way here. I'm just going to isolate for x. So it's 1,010 minus y. And then I'm just going to replace that x in here. I'm going to replace this x by this equivalent expression of 1,010 minus y. Let's see what happens. So we get 450. Instead of x, I'm going to write something else. I'm going to do a substitution. I'm going to substitute for x this thing, 1010 minus y. And now I've got to work this out. Notice our equation is completely in y now, which is a good sign. It means we can make progress on it. What's 450 times 1,010? It's this number. Minus 450y plus 510y equals this quantity. Let's, these two combine here to give us 60y, right? And I bring this over, I get 494,700 minus 454,500. It gives 40,200. And then I divide both sides by 60. When I divide that by 60, I get 670. So it looks like 670 of the second type of computers were sold. How do we get x? Well, that's easy. I just look up here. X is 1,010 minus whatever y is, right? And I've just found what y is. It's 670. So 1,010 minus 670 is 340. So now we know how many of each type of computers are sold. That's what they wanted, right? How many of each type of computers are sold. So do we stop there? No, we should really give a little English sentence because the question was asked in English, so we should give our answer as a sentence. So they sold 340 of the first kind of computer. Did they use the words first kind and second kind? Yeah, well, pretty much. The first sells for that and the second. So that's fine. They sold 340 of the first kind of computer, which is the cheaper one, right? And 670 of the second kind. So that's... Now, it depends on your teacher. Some teacher, if you just put your box around X and Y like this and call it done, they'll give you full marks. But some teachers with a word problem like this, they really want you to give a sentence as an answer, and I consider that good style as well. But if you have a pure math problem like we were doing back here on number 10, where it's just pure algebra and stuff, your answer there, you just put a box around it and call it done. But if it's a word problem, you should really give a little sentence as an answer. Okay, so that completes 11.